Hello everyone, it's Benny, and in this video, we're going to be extending our OBJ loader. Rather than just loading vertex positions, we're going to load some other things like texture coordinates and normals, and we're even going to be doing some mesh optimization so that we'll convert sort of the OBJ representation of the model into something that's as optimal as we can reasonably get it for actually drawing. So yeah, we're going to be doing quite a bit. This is going to span a few videos, so get ready. I'm going to start by creating a new package for this. I'm going to call it mesh loading. How about that? Not loader. And the reason I'm doing this is because I'm going to create a few different classes to make this sort of more generic, less specific to the OBJ format. Because at the end of the day, yeah, we're writing an OBJ loader, but I want to make this reasonably simple to add on support for loading other file formats without having to write very specific, very detailed code for every single format. I want to reuse as much as possible. And the first part of that is a class I'm going to call indexed model. What this is going to do is this is going to sort of be the format we're trying to load all our different model formats into. It's not going to be the mesh, it's just going to be, well, a representation of the model that's sort of file format independent. And right now, this is just going to be a lot like our vertex. It's going to have a position, a texture coordinate, and normal. And well, or should I say, an array list of each of these. So yeah, just a list of all the different positions, texture coordinates, and normals in the mesh. And the reason I'm going to be doing it like this, rather than having an array list of vertices, is because I want, well, the vertex is very specific to the GLSL shaders and whatnot. You know, this is the data that's being sent to the GLSL shader, and I want the model to be as reasonably independent from that as possible. If I want to create a vertex that has, say, more than this, maybe it has bone data for skeletal animation, I don't want to necessarily have to make every single model format include skeletal animation stuff in here, because it might not necessarily have that. So, yeah, that's the reason I'm separating it out like this. And really, that's most of what I want in here. Except I want to rename this from pos to positions, texture coordinates, and normals. And I went ahead and created a constructor and some getters off screen because they're pretty straightforward. There's nothing that interesting about them. Just initialized the array lists and returned what the getters are supposed to be returning. I did, however, add an array list for indices because I completely forgot about these. They serve the exact same role they serve in the mesh. They're going to determine, well, the draw order. We're going to draw this position, then this position, then this position, then, well, and the associated texture coordinates and normals and whatnot, you know. Same role there. So yeah. And with that, let's go ahead, and now that we're done with our generic, this is what we're going to convert all the different model formats into, let's create a class specifically for OBJ models. I'm going to call it OBJ model. And this is actually going to be a lot like the indexed model. The idea here is to sort of represent how the model format works internally, so that, well, we could very easily load one of these classes. And fortunately, the OBJ model is very, very close to the way our internal indexed model format works. In fact, the only difference is, rather than indexing these things, well, together, like position 1 is also texture coordinate 1 and normal 1, and position 85 is also texture coordinate 5 and normal 85, it indexes them individually. So I can say, take position 7 and texture coordinate 12 and then normal 5, and then, hey, that's a new vertex. So I'm going to create one final class. I'm going to call it OBJIndex. And this is just going to have, in fact, this is going to be pretty much a struct, not really a class. It's just going to have public int, call it vertex index. In fact, yeah, there. Just duplicate that, and we're going to have one for vertex index, one for text coord index, and one for normal index. And so yeah, that's going to be the difference. Rather than an OBJ model, rather than having an array list of indices, it's going to have an array list of OBJIndex. And great! There's only one more thing I want to do here, and that is actually, you know, load the OBJ model. So, unfortunately, since our class is very, very similar to the way the OBJ model works internally. That's going to be very straightforward. So the OBJ model is going to take in some string file name. And after it initializes everything, it's going to do pretty much what we're doing right here in our mesh class in the load mesh function. So, yeah. Yeah. I was thinking about doing something else, but no. So I'm just going to copy this from the buffered reader and onwards. In fact, yeah, let's copy that. I'm going to paste it in. And of course, this isn't going to quite work out because, well, yeah, this isn't exactly, you know, this isn't exactly the way our OBJ model is storing things. It's sort of like doing a direct conversion to meshes. So yeah, we're going to need to change this up a little bit. So, here, continue. Oh, don't worry about that. So, what I'm going to do right here, where I'm normally adding to vertices, I'm just going to add to my positions, because that's what this is representing. V is representing some vertex position. And it's not going to wrap it in some ridiculous, oh, it's a vertex class. No, just basic vector 3f. And there. Faces, I'm going to worry about in a moment. In fact, for now, I'm just going to comment that out. Now let's test for a few of the other things in the OBJ file format. This, other than vertex, I'm going to test if token sub 0 equals vt for, well, vertex texture coordinate. In that case, guess what? It's texture coordinate. So, what I'm going to do is I'm going to say textcoords.add a vector 2f of all this, and I'm just going to delete value of 3 because we don't need that anymore. And apparently I don't need this anymore either, which is great. And finally, I'm going to, in fact, copy v one more time, because there's one more thing we're going to look for in our new and improved OBJ loader. vn, vertex normal. And here it's just going to say normals.add that. And great, that's really just about all the data in the OBJ model that we care about, at least. Only difference, well, other than one, we don't need to add it to here anymore, because we're doing just that. We're adding all the data here. We don't need to do any extra conversion, because we're just trying to load it all into an internal representation that's as close to the way the OBJ model stores data as possible. Yeah, so we don't need to do any conversion. The final thing we want to do, though, I'm getting off topic, sorry, is the faces. So I'm going to uncomment this for a moment, and we're having a little bit of a problem. Because this isn't quite the way that, well, this technically will get the vertex index, but we want the indices for vertex textures and vertex normals as well. So we're going to need to do a little bit more than what we've done just here. And a big reason why this is a little bit trickier is because OBJ models don't necessarily have to have vertex texture coordinates or vertex normals in their face indices. So the way I'm going to resolve this is by having two booleans. One boolean is going to be called has text coords, and the other is going to be a private boolean has normals. And by default, these are going to just equal false. We're going to start off by saying we don't have any. And I'm going to set them when I'm parsing the indices. The reason I'm going to be setting them there and not when I actually encounter a vertex texture coordinate or a vertex normal is because just because the model has some of these in there doesn't mean it actually uses them. So if it is listed in face, then it actually is addressing them. So that's the reason I'm putting them in like that. So yeah. And since this is going to be a little bit non-trivial, I'm going to walk through it once in here, then I'm going to move that out into helper method so that it's a little bit easier. So what we're essentially going to do is we're going to want some string I'll call it not token. Okay, you know what? Fine. I'll create a private helper function, private OBJIndex, called parse with lowercase, parse OBJIndex. It's going to take in some string token, which is going to be essentially this, and it's going to do exactly what it says on the tin. It's just going to parse the OBJIndex. And we're going to be passing in tokens, like tokens of 1, tokens of 2, tokens of 3, and whatnot into here. So here's what it's going to do. I'm going to have some string. I'm going to call it values, which is going to be equal to token.split by just a slash. And there. So now I have an error. String array of values, excuse me. And the way this is going to work is very simple. If values.length is greater than 1. Well, if it's greater than 1, then has text words is true. And else, otherwise, if values.length is greater than 2, wait, it's not supposed to be else, but I'll fix that in a moment. Then, has normals is going to be equal to true. And that's pretty much the way I'm going to determine if we have texture coordinates in here. And in fact, yeah, this shouldn't be else. This should actually be sort of nested. So yeah, there you go. And this is also going to be the way I actually add the different data to my, well, to my OBJIndex. So I'm going to have some, because I'm going to have some OBJIndex called result. It's going to just start off initialize to new OBJIndex. And I'm going to start by saying result dot vertex index is going to be the very first one. Because remember, that's how tokens sub 0 is going to be. Okay, I'm going to be doing this, okay? Same thing I did before, except with values sub 0. And not splitting it, because I already did the splitting. There. And I don't need that thing anymore. There. And the reason I'm doing it like this is because, remember, the way the OBJ indices was laid out is that the vertex index slash texture coordinate index slash normal index. So that's why I'm splitting it by slashes here, so that it splits it up into, theoretically, just a string of the vertex index, then texture coordinate index, then normal index. And then, right here, the next one, if it's there, is going to be text coordinate index, which is going to be values of 1. And the final one is going to be normal index, which is going to be values of 2. And then I'm just going to return the result. Or better yet, I can actually just make this... Yeah, actually no, let's do it like this. This is more descriptive. What I'm going to do here, finally, now that I have my helper method out of the way, indices.add. Going to be tokens sub 1. Wait, forgot the function. Going to parse the OBJIndex tokens of 1. There. Just like that. And then 2 and 3. One final thing, though, is we are going to want to triangulate things. Like, for example, this right here would triangulate a quad. But we want fully generic triangulation. In theory. The way I'm going to do it here is it's going to triangulate convex polygons. If it's non-convex, then, oh well, just do that in the model editor, you know, triangulate it there. But yeah, I want at least basic triangulation in here. So, what I'm going to do is very simple. Actually, that's a good point. Okay, no, I know what I'm going to do now. I'm going to say for int I is going to start as equal to 0. Okay? In fact, you know what? Here, this is going to make more sense if I write out the inner loop first. So, forget about the looping condition for a moment. Okay. What I want to start out with, or what I want to eventually do, if I can ever type the plus thing there, is something like this. Because as you see, that's sort of the pattern to it. This will triangulate the thing in sort of a triangle fan, where the sort of pivot of the fan is the first vertex. And, well, yeah, it's that simple. And that does triangulate convex polygons. As you see, that's sort of what we're doing here, except not generic. What I want to do, though, is something that will do this for every single, well, for the appropriate amount of times to get, all the tokens in place. So, here's how I'm going to count. I'm going to say it's less than tokens.length, but I'm going to subtract something. And in fact, I'm going to subtract 2 and count up. Because this way, I is going to start at 0. If tokens does have a length of, say, 4, which is what it should... Oh, right, it should be 3, excuse me. If it has a length of 4, which it should if it has just one... It should have at least 4, because, that will be one triangle. So, if it has a length of 4, then this is going to be 1. It's going to go through it once, add one triangle, and then break out. If it's 5, that means it has a quad. So it's going to go through once, then I is going to count up, it's going to add the quad, and go on. And that's the way our big, gigantic parsing scheme is going to work. And with that, finally, we should at least have the OBJ model loading in. So, let's test it out. Let's go into load mesh, and let's see if this crashes. Of course, I'm going to need some model to test this with, so I'm going to go ahead and create that right here. I'm not going to do anything fancy, just make a very basic mesh. So I'm going to hit delete, enter, just get rid of what's on there. I'm going to hit shift A, going to add a mesh. Going to add in the monkey. Going to zoom in and rotate around with the middle mouse button. Not that it particularly matters, it's just, looking at the mesh. And yeah, I'm going to hit tab and hit U to unwrap, because I want appropriate texture coordinates for this. I'm just going to do Smart UV Unwrap and click OK. And if I go to the UV editing thing, this is what all the texture coordinates look like. Again, not that it matters, it's just an example mesh. So now let's go back to the... Well, hit tab again to go back to the model editing mode. I'm going to hit the little tool thing here, the wrench. And I'm going to add a subdivision surface. Going to give this a little bit more detail. Going to increase the view to 2. So yeah, it should be a very smooth monkey head. And honestly, that should be good. So let's export it as OBJ. Let's check our parameters. You know what? This looks pretty okay to test it. I'm not going to include normals here. You probably want to include normals in a production environment, but I'm not, just because, well, just to test our normal calculation that we're going to eventually put in. Not going to triangulate it to test our triangulation. And, well, let's just go ahead and do it. I'm going to export to the desktop, and I'll call it monkey3.obj. Sure. And export. And great. So now I have my, well, that. So let's add it to our resource folder. I'm going to create a new folder for this, models. And what I'm going to do here is very simple. We're just going to take our monkey stuff, drag it in. Drag it in. There we go. And I'm going to delete the material because I don't care about the material. And there, that should give us an example mesh. So, okay. Now for the model, I'm going to have, an OBJ model. I'm going to call it test in my load mesh function. It's going to equal new OBJ model. It's going to take in a file name, and I'm going to have, just like I have right here right now, ./res/models plus file name. And there, this should load in the model, and unless something goes horribly, horribly wrong, this should run once I actually, use it for something. And in fact, I'm not going to actually put it in the scene yet. I'm just going to create some mesh, temp mesh, new mesh. Not going to do anything with it. Wait, Do I have a constructor that takes in a file name? I forgot if I added that yet or not. I do! Okay. Cool. So in that case, I'll just say monkey3.obj. There. And finally, if we did everything right, this at least shouldn't crash. And it crashes, okay. /res/models/res/models, okay, that's not what... Oh, right, because I already did that inside of the... Oh, inside the OBJ model loader thing, so... Okay. I'm actually going to get rid of that in the OBJ model, because, well... yeah, I want that to be part of the mesh for now. And there. So, hey, look, it didn't crash. Now, we aren't converting it into an indexed model that we can actually render yet, and we aren't doing anything else particularly interesting with it. But hey, it's getting it started. We are indeed loading in an OBJ model in its internal format. We're not doing anything with it, but it's being loaded. So thank you. Hope you enjoyed, hope you learned, and in the next video, we're going to go about converting the OBJ model from its internal format to our generic indexed mesh format. So thank you, and see you then.